Moving on from factoring today. Hopefully you guys did well on your factoring quiz yesterday, and don't need any supplemental practice, although it wouldn't hurt. So today's goal is a new section, and we're going to combine a whole bunch of skills that we already know to be able to do today's lesson. So our objective in section 2.3 is to learn how to rewrite quadratic functions in their different forms. Just move this out of the way. Okay. This is a shorter section just because it does involve skills you already know. So it's pretty much just one day of learning it, one day of practicing it, and then it's review and test time. So we're approaching the end of the first half of the unit. So you guys will have a test on day 4. So again, today you're going to learn it. Tomorrow you're going to practice it. Then there's going to be a review for the mid-unit exam, and then you will take the mid-unit test. So looking at rewriting. First, we're going to go ahead and go from intercept form into standard form. That's the first examples. Okay. Intercept form, that's also known as factored form, so it's going to be already factored for us. So all we have to just do is just distribute it all the way out to get it back into standard. You can't just do the inner outer like we were doing when we were checking to see if we factored correct. You got to do all of the distributing. So if I gave you, for example number 1, f of x equals negative times x minus 4 times 3x plus 7. We're going to deal with the a value of negative 1 last and start off by distributing the x minus 4 to the 3x plus 7. We did this back in Unit 1 when we learned how to multiply functions together. So I will have 3x squared plus 7x minus 12x minus 28. I'm going to combine like terms in the middle. And this is not done yet, though, because we still have to distribute that original a value. So I have to put that back in parentheses and distribute the negative 1. I'm also going to make sure I bring back my f of x because it does need to be in function form. And when you distribute a negative 1, the numbers don't change, but the signs change. And that's it. That's all you really have to do to go from intercept form to standard form. It's going from factored, and then you're distributing it all out into standard. ax squared plus bx plus c. So I'm going to have you guys try one of those on your own. It's going to be a little more challenging because the a value is going to be a fraction, but I still want you to try it. So when I'm done writing, go ahead and hit pause, try it, and then check your work with my work. So I'm going to distribute the x minus 8 factor to the 2x minus 9 factor. Combine like terms. Put it back in parentheses and distribute my 1/2. So half is the easiest fraction you can work with. You're just dividing them by 2. I don't want any decimals though, so when you divide it by 2, it's a decimal. Leave it in fraction form. Half of 2 is 1x squared. Half of 25 will be a decimal, so I'm going to leave it as 25 halves. Think about putting that over 1 and multiplying the numerators and multiplying the denominators. So you get 25 halves x. And then half of 72 is a whole number. You're going to get positive 36. And that's it. That's going intercept form to standard form. Of course, it's not all there is in this lesson because we can still go from other notations. So we are going to go now from vertex form into standard form and try 2 of those. When you're rewriting, you're also finding equivalent notation. So just because one of them was originally an intercept and then you transformed it to standard, everything about the intercept form still stays true. So this right here, this original, and our new answer are equivalent, meaning in the original problem, because the factor was x minus 4, that means 4 is an x-intercept. Well, 4 would still be an x-intercept in standard form. We just don't know how to find that yet, but it still would be an x-intercept. Negative opens down, negative opens down. So that information is not going to change. The way these graphs look would be identical no matter what form I give it to you in. So keep that in mind. When you're writing an equivalent function, all the characteristics should not change. Just the way the equation looks should change. So here's our first vertex to standard. F of x equals 3 times x plus 4 squared minus 9. We need to go ahead and get this into ax squared plus bx plus c form, starting off with the exponent. When you have x plus 4 squared, that means x plus 4 times another x plus 4. That's going to be step number 1. Okay, we have to distribute. That will give me x squared plus 4x plus another 4x plus 16. Combine my like terms in the center, throw it back in parentheses, and I still have my a value and my k value to take care of. A value comes next. So we're now going to distribute the a. And bring down the k. And the very last step is to combine the k. Make sure you save that to the end. A lot of students try to do that too soon. It should be distribute, then distribute the a, and then combine with the k. So our final function, now in standard form, is 3x squared plus 24x plus 9. I'm going to throw one up on the board for you guys to try. And again, it's going to be messy. Throwing a fraction at you. Good fraction practice, especially for when you guys take the SATs, and there usually is a no calculator portion that involves fractions. So you've got to be comfortable working with them. Hit pause, try it on your own, check with mine. And when I say try it on your own, actually try it, guys. Don't just sit there and wait for an answer to be given to you. Check to see if you're understanding it and give it a shot. So we're going to start with the x minus 6 squared. Combine my middle terms. Throw it back in parentheses, and we're going to take care of the a value next. K is last. All right, 2/5. Not as nice as a half. Definitely going to put these under 1 to help me with my multiplication. So negative 2/5 times x squared is going to stay negative 2/5 x squared. Negative 2/5 times negative 12 is going to become positive 24/5 times x. Double check to see if you can simplify that fraction, see if there's a common factor, but there's not. So that's done. And then negative 2 times 36 is negative 72/5. Again, that fraction cannot be simplified. I'm going to drop down my plus 11 and throw that over 1. I have to now combine these last two. Here's where you really got to stay with me. Adding and subtracting fractions, we need common denominators. So I'm going to multiply my second fraction both by 5. That'll become negative 72/5 plus 55/5 to get a common denominator. Now I can go ahead and combine my numerators. So if I do negative 72 and I add that to 55, I'm going to get negative 17/5. I got to put everything all together. Oops, move that out of the way. So I will have f of x equals negative 2/5 x squared plus 24/5 x. And then when I combined the c value with the k value, we get a final term of negative 17/5, so minus 17/5. Definitely a little bit more challenging with the fraction, but the same skills, and it's using skills that you guys should still know as high school students. Now we're going to go into vertex form. I'm skipping going into intercept form because that's what we just spent the last 7 days doing. To go into intercept form, you factor. So we're not going to do any of that today. So last examples are either going to be intercept or standard form into vertex form. So what information do we need to write an equation in vertex form? Think about that for a minute. What do you need to know to write an equation in vertex form? Pause it, think about it. If I want to write an equation in vertex form, I need to know the A, the H, and the K values. Now the H and the K stand for vertex. We can find the vertex in these other forms and use them for H and K, because X of the vertex and Y of the vertex is still a vertex. That's what we're going to do. We're going to look at our intercept in standard form, get the vertex, and use it for H and K. And the A value should not change at all. So let's try it. F of x equals x squared minus 8x plus 11. This is currently in standard form. The 8 and the 11 are not H and K. Those are not the vertex. So we want to find the vertex in standard form, we have to do negative b over 2a and sub that value in. So negative b, when the b is already negative, becomes positive 8 over 2 times a, so 2 times 1, 8 over 2. I get an x coordinate of 4. This is my h value. X of the vertex is h. I'm going to sub the 4 into my standard form equation and get my y value of the vertex. That'll be 4 squared minus 8 times 4 plus 11. If I go ahead and use my order of operations, I'm going to get 16 minus 32, which is negative 16, plus 11 is going to give me a y value of negative 5. That's my k. K is y of the vertex. The a value shouldn't change. So what was the a value of the original function? Yep, it is 1. So the a value in vertex form should also be 1. So my final equation is going to be f of x equals an a value of 1, which you don't have to write, parentheses, x minus h, that's the formula, x minus h, so x minus 4, squared, and then plus k. But because k is negative, it'll be minus 5. And we are now in vertex form. So want to do vertex form? You got to get the vertex to use for your h and your k. You guys are going to try this one on your own. Go ahead and hit pause and try that one, and then check your answer with mine. Going to again find my my vertex. So negative 12 is positive 12 over 2 times a. We get 12 over negative 6, which is negative 2. That's h. X of the vertex is h. Sub it in to get y of the vertex. Negative 3 times negative 2 squared minus 12 times negative 2 plus 5. This is going to become negative 3 times positive 4 plus 24 plus 5. Negative 12 plus 24 plus 5. And if I combine those from left to right, I'm going to get 17. That's my k. A value shouldn't change, so my a value should stay a negative 3. Therefore, my function in vertex form is going to be negative 3, x minus h. When you do x minus negative 2, you're going to get positive 2 squared, and then plus k. Our last example is still going to be going into vertex form, but it's not going to start in standard like these two. It's going to start in intercept, and then we'll do a summary. So this one, don't hit pause. Work through it with me. I'm going to give you f of x equals 2 times x plus 3 times x plus 5. Okay. You have two options with this. You could first distribute it into standard and do it the way we just have been doing it. Or you know how to find the vertex in intercept form, so let's just do that. So we start off by getting the x-intercepts, setting these equal to 0. So my first x-intercept is -3, and my second one is -5. Now that's still not the vertex. Neither of those numbers are h or k. To get the x of the vertex, we average those. So I'm going to add those together. When you add -5, it's really just subtracting 5, and we have to divide by 2. And -8/2 is -4. That is the x of the vertex. That is my h value. So to get the h, you have to average your x-intercepts. Y of the vertex, sub that number in. So 2 times -4 plus 3 times -4 plus 5. Combine in your parentheses, you'll get -1 and +1. Remember, those three numbers are being multiplied, not added or subtracted. And 2 times -1 times +1 is -2. That is your k. A value, same rule, doesn't change, so my a value is a 2. Sometimes if these x's aren't a coefficient of 1, you also would need to take that into account when you're trying to figure out your a value. So for example, if that was 2x plus 3, you have a coefficient of 2 inside and a coefficient of 2 outside. That would technically make your a value a 4. It's a little trickier. I probably won't throw any out there like that for you, but that would be a big difference. So my final function is going to be 2 parentheses x minus h. So when you minus -4, again, becomes +4 squared, and then plus k. So if you want to get it into vertex form, you got to find your vertex to use as your h and your k. And the way you find your vertex varies depending on what form I give you. That's all we're going to do for today. So I'm going to have you hit pause on this video here in a second. The video is going to keep going with a summary. But if you don't have some time to write that summary today, then you're going to write it on the beginning of class tomorrow before you work on a practice type 3. Okay, so hit pause. Here's the summary unless there's still time in class for you to write this down. So this is a summary of how to go from one form into another form. So if you want to go from vertex form or intercept form, and I'm abbreviating here, into standard form. So you're going into standard form, which is ax squared plus bx plus c. Then you're going to have to go ahead and distribute and combine like terms. Okay, so vertex or intercept form into standard is where you have to just distribute everything out, make sure you're doing it in the correct order, and combining your like terms. If you want to go to standard form to intercept form is also known as factored form. So you factor. That's what you just spent 7 days doing. If you want to go from standard or intercept into vertex form, which is what we just finished practicing. If I want to get into vertex form, we have to find the vertex first of whatever form it was given to us in, and then sub in your a, h, and k values to get it into vertex form. And the only one that we didn't do, because there's no direct way to do it, which is vertex to intercept. So it's going to start in vertex form, and you need to get it into intercept form, which is factored. You can't do it right away. So what you would have to do is you'd first have to distribute it into standard form, because you do know how to go from vertex to standard. And once you've distributed it into standard form, then you can factor it in the intercept form. And that's the summary. So you guys will have the remainder of class to work on the type 3 practice. And just another reminder, tomorrow you guys are going to have a quick quiz on this and review for the mid-unit exam that you'll have the day after. Last year averages were at 85 and 86%, so it's fairly high averages. So I have high expectations that you guys will do well on that test as well. Bye guys.